In this demo, we will be adding indexes for select queries to improve its performance. Thing to keep in mind is like this particular demo is not going to worry about any regression that these indexes will be causing as far as insert, delete, or update queries are concerned. This demo is purely for improving the select queries. Yeah. So I'm going to use Database AdventureWorks DW for this demo. I'm going to create a table called table1 underscore temp. I will be using select star into from table 1. I'll be creating a primary key on column 1 of object table1 underscore temp. Likewise, I'm going to create a table called table2 underscore temp. I'll be utilizing select star into again, and it will get its data from table 1. I'll be creating a primary key on column 1 for table2 underscore temp. I'll be enabling set statistics IO on, and I'll be executing this query, which basically selects column 3 and column 2 from table 1 underscore temp and table 2 underscore temp respectively. This query joins table 1 underscore temp and table 2 underscore temp, and the join condition is on column 1 for each of these tables. And the predicate is table 1 underscore temp column 2 is equal to Raja, and table 2 underscore temp dot column 3 is equal to 4. Let's enable the execution plan, and then let's execute this query. The query completed, it returned close to 100 rows. Let's look at the execution plan. So if I look at the execution plan, what I'm able to see is like I'm able to see we have a cluster index scan that is happening on table 2 underscore temp, and then an index seek, cluster index seek on table 1 underscore temp. So basically we are utilizing the cluster index for each of these operators because those are the only index that is present on this table. Now, if I look at the cluster index scan on the table 2 underscore temp, what I'm seeing is like I'm estimating close to 100 rows, reading close to 1,18,890 rows. That is basically I'm touching each and every record. I'm basically reading each and every record, and then I'm returning close to 100 records. If I look at the details again, estimated number of rows per execution is 100. Actual number of rows read is close to 1,18,890, which is basically like I'm reading each and every row on that particular table, and then I'm returning close to 100 rows. And likewise, if I look at the cluster index seek, estimating 100 rows, I'm reading 100 rows, and then I'm returning 100 rows. And the nested loop filters the data across and then gives it to the select operator. So if I look at the stats details here, what I'm able to see is like table 1 underscore temp is basically doing close to 215 logical reads, and table 2 underscore temp is basically doing close to 572 logical reads. So now what I'm going to do, I'm going to concentrate on table 2 underscore temp because this is where we have this cluster index scan, and also the amount of logical reads seems to be very, very high for table 2 underscore temp. So what I'm going to do as far as table 2 underscore temp is concerned, I see that we have a predicate on column 3, and also like we have column 2 in the select list. So what I'm going to do, I'm going to create a non-cluster index ix underscore test on column 3, and then I will include column 2. Let's execute that. This is completed. I'm going to execute the same query that was executed previously. Let's make sure execution plan is enabled. Let's execute it. And now if I look at the execution plan, what I'm able to see is like now I'm not doing a cluster index scan. Instead, I'm doing an index seek, and let's look at the stats there. So now what I'm seeing is like I'm estimating 100 rows, I'm reading 100 rows, and then I'm returning 100 rows. And now if I look at the stats, what I'm seeing is like table 2 underscore temp is not doing 572 logical reads. Instead, it is just doing 4 logical reads. Yep, if you see here, it is just 4 logical reads. But table 1 underscore temp is not doing 215 logical reads. Instead, it is basically performing 366 logical reads. So now what I'm going to do, it's time we improve table 1 underscore temp. So what I'm going to do, if I look at the query, the predicate as far as table 1 underscore temp is column 2, and then on the select list we have column 3. So what I'm going to do, I'm going to create a non-cluster index ix underscore test on table 1 underscore temp on column 2, and I will include column 3. Let's execute that. Now, if I look at this query performance, let's enable the execution plan. Let's execute it. Now, what I'm seeing is like I'm getting a merge join, and what I'm seeing is like as far as table 2 underscore temp is concerned, I'm estimating 100 rows, reading 100 rows, and then returning 100 rows. And likewise for table 1 underscore temp, I'm estimating 101 rows, reading 100 rows and then returning 100 rows, and we have a merge join. So now let's look at the stats. Now what I'm seeing is like we are doing a logical read of 4 for both table 1 underscore temp and table 2 underscore temp. And if we compare it with the initial one, what I'm seeing is like after creating these two indexes, as far as table 1 underscore temp, we were able to reduce close to 50x logical reads. And as far as table 2 underscore temp, we were able to reduce it by 100x. So that is what we were able to achieve. The thing is like again, this is purely from the select perspective. Adding indexes is definitely going to have an impact as far as your write operations are concerned. So that is something we need to look at. That needs to be a balance as far as improving the select query by adding indexes and deteriorating the performance of the write queries because it has to manage these indexes. But this demo is basically to show you like how we can improve these select queries with indexes and how we will be able to reduce the logical reads to a greater extent if we can add proper indexes. That's it for this video. Thanks for watching. Have a great day. Jai Hind.